Welcome to springlib.
Hi everyone. So what we have here is a problem of a smooth can of mass 3 kilograms that is lifted from a feed to a ramp by a rotating rod. The rod maintains a constant angular velocity of 0.5 radians per second, and the path is given by r is equal to 1.2 cos theta. So what we're asked to do is solve for the force that the rod exerts at the can at the instant of theta equal to 30 degrees. And what we're asked to do, and how we're going to go about doing this, is by using Newton's second law and our knowledge of normal and tangential motion in the r and theta directions, and combine that with our equations of motion in r and theta to solve for this force. So what we're going to first say is that we know that r is equal to 1.2 cos theta. Therefore, r dot is equal to negative 1.2 sine theta times theta dot. And then r double dot is going to be equal to negative 1.2 cosine theta times theta dot squared minus 1.2 sine theta times theta double dot. So what we can do is at the instant of concern, so we know that at theta equal to 30 degrees, we know that theta dot is equal to a constant of 0.5 radians per second, and that theta double dot is equal to 0. So knowing these pieces of information, we can go ahead and plug into the equations that we had just solved for r dot and r double dot and r. So we know that r is equal to 1.0392 meters, r dot is equal to negative 0.3 meters per second, and that r double dot is equal to negative 0.2598 meters per second squared. Using these pieces of information with our theta dot and theta double dot and theta, we can solve for our accelerations in the radial and theta direction. We know that AR is equal to r double dot minus r theta dot squared, and this is equal to minus 0.5196 meters per second squared. And we know that a theta is equal to r times theta double dot plus 2r dot theta dot, and this is equal to minus 0.3 meters per second squared. Next, what we're going to do is we're going to draw our free body diagram. Here's our can, here's our normal force, and here is the force from the rod, and here is our weight force. Here is our theta direction, and here is our r direction, and we know this angle to be 30 degrees. So by resolving these forces in the normal or in the r and theta directions, we see that the net force in r, which is equal to m times ar. So resolving our forces in the radial direction, we see that n cosine of 30 minus 3 times g sine 30 is equal to m ar. This gives us an n that's equal to 15.2 newtons. Next, what we can do is we can do Newton's second law in the theta direction. So we know that the net force in theta is equal to m times a theta, and this gives us F plus n sine 30 minus 3 times g times cosine 30 is equal to m a theta. We just solve for n, and all we have to do is solve for F, and this gives us an F that's equal to 17.0 newtons. And this is our final answer.